My name's Colin Cureton, and I work as the Director of Adoption and Scaling with the U of M Forever Green initiative. And I'm co-presenting today with some of my U of M colleagues, as well as a close farmer partner, Kurt Kimber, on the first phase establishment of a Go First Farm, a UMHDI hybrid hazelnut Go First Farm in Minnesota. I'll just tee up the agenda, and then I'll hand it off to Kurt. Next slide. Okay, so today you'll be hearing the big picture from Kurt, who I think I really appreciate working with Kurt. Really centers climate justice in his philosophy, and we'll hear from him about why and how he's getting involved in hybrid hazelnut production. And then Lois Braun will give an intro to the Upper Midwest Hazelnut Development Initiative, bit of background on this multi-state, multi-institution collaborative. I will then talk about how the University of Minnesota Forever Green commercialization team kind of merged into that work over the last year on recruiting our first Minnesota-based UMHDI Go First Farm. And then Andrew Leach and Kurt will tag team talking about the establishment process and learnings, both from the grower perspective and the institutional support perspective. And we'll kind of end with a bit of a call to action around continued Go First Farm recruitment. So with that, I think, Kurt, take it away.
And Colin, could I ask you to be timekeeper?
And yes, I will be timekeeper. Thank you, Kurt. For our team, I think we're targeting around 7-8 minutes per section, so we have good opportunity for discussion at the end, and I will give you a 1-minute warning.
All right, so why do we want to plant hazelnuts? Why do we care about hazelnuts? Okay, so just overview of our farm, 240-acre family farm, 30 miles south of Minneapolis. Our mission is to grow plant-based food, primarily agronomic, and introducing agroforestry in there now too. We're organic certified. And we want to investigate resilient, sustainable cropping systems. We have some erosion threats on our farm. We have some 2,000-foot long, 4% slopes. Unfortunately, we've washed about half of our topsoil, half of our Midwest topsoil into waterways already. Topsoil is fundamentally necessary for civilization. Some of the practices we're implementing on our farm, as you can see, contours. We have prairie strips in between the contours, 30-foot wide. We're growing Kernza, a perennial grain on our farm. And then this hazelnut opportunity is kind of a continuation of the practices that we're investigating. You know, producing food going into the future. So everybody on the call knows the climate is changing. We have, heat, drought, flooding, high intensity rainfall events. Crop yields are forecast to decline by 30%. We need climate resilient cropping systems. The world population is forecast to continue to increase. So we've got declining production and increasing demand. How do we square that? How do we protect our soils? I am particularly concerned about these high intensity rainfall events, and given our farm has some erosion vulnerability. Perennial agriculture really has a lot of great attributes to respond to this. They can ride through the drought and flooding events. They armor the soil against high intensity rainfall events. I'm very I think investigating these perennial cropping systems and woody agriculture are reasonable things to be doing in this predicament humanity and the biosphere finds itself in. Anything we do, it needs to be replicable and scalable. We have to drive massive system change. everybody, I think everybody's aware that the food system, the human food system has an enormous planetary footprint. It's right up there with energy production. And so we've got to we've got to be thinking about ways to address again these existential challenges in front of us. And then I like to talk to people about we have to be thinking about we can't be constrained by thinking what is possible. That's typically much too small. We have to be thinking about what is required.
Okay.
Okay, so now shifting gears back to this particular project and planting hazelnuts in general. So so the one thing that was different for me is that everything I've been doing up till now has been annual agriculture, or Kernza is kind of like a 3 or 4 year time frame. Hazelnuts are like kind of forever. It's amazing how long hazelnuts will live, 500 to 1,000 years. So that's some new thinking that has to emerge. And then, growing zone, precipitation, your soil types, water holding capacity, the slope. We're intending to do mechanical harvest, so that's going to limit the maximum slope that this particular hazelnut system could be planted on. Then 2 big ones, weeds and I guess rodents. So what was the previous weed pressure on the land that you're considering planting hazelnuts to? And then think from what I've read, having an open area where raptors can patrol and make rodents feel less welcome. And then pocket gophers are a pretty significant threat to hazelnuts, and so how do we manage those? And then consider row spacing, and then the spacing of the plants within the row. We chose 15-foot row spacings because we intend to mechanically harvest. What are we going to do for ground cover? And in this particular example, this is a 3-year-old Kernza field. So its grain production is declining, but as far as a forage, it can go multi-decade. And then also, what kind of what's your genetics that you're going to be planting, and that's a big part of the Gophers farms. So
you got about 2 minutes, Kurt.
Yeah, good, Colin. Thank you, man. Great book for anybody considering planting hazelnuts, hybrid hazelnuts by Philip Rudder and 2 other people. Just part of choosing our particular field was that we had erosion. There was significant slopes on this field, and in the upper right you can see some outwash from erosion from that field. We've had so another thing we wanted to do is we wanted to have a collaboration. That's and so yeah, Caleb Langworthy, who's on this call here, and Savannah Institute employee, drove some significant collaboration here. First thing was that the Minnesota, Caleb asked to have hybrid hazelnuts be allowed as part of practice 612 tree and shrub planting. And so he worked with a local NRCS person, then that went to the state, and then it went to the federal agroforester to get approval for this. So I think just driving agroforestry questions through NRCS and getting them aware of that is great. And then another just tremendous set of collaborations is there's a set of recurring meetings, fostered from this, collaborative relationship between the Minnesota Sustainable Farming Association, our extension agency, NRCS, our Board of Soil and Water Resources, the Xerces Society, and the Savannah Institute. So great work, Caleb, and I'm delighted about this, making driving agroforestry into all these organizations and doing mindshare, creating mindshare. All right, that's my spin here. Lois, ready to take her off?
Okay. My name's Lois Braun, and I work at the University of Minnesota as a hazelnut breeder, and I also do agronomic research. So next slide. So I've been tasked with explaining what UMHDI, or I call it UMHDI, is, Upper Midwest Hazelnut Development Initiative, and also to explain a little bit about the plant breeding. UMHDI was founded in November 2007, so we're 16 years old now. And at our founding meeting, we identified 4 focus areas. Breeding and propagation, which go hand in hand, because for perennial crops, or for, I should say, horticultural crops, by definition, when you have advanced cultivars, they are vegetatively propagated. Then agronomics and production systems to fit the plants that we breed, because we are working with bush-type hybrid hazelnuts, which are quite different from the European hazelnuts that are grown as trees in Oregon. So we have completely different production systems and recommendations. So that covers things like fertilization, pest control, plant spacing, pruning, coppicing, things like that, weed control, that will be different than what Oregon has recommended. Likewise, our harvesting is over the top, not swept from the ground the way the hazelnuts in Oregon are. And so we're going into new territory there. And processing, we've got smaller nuts. So the equipment developed for Oregon hazelnuts wasn't working for our material. So we had to develop our own processing equipment. And none of those 3 objectives are any good if we don't make it possible for growers to actually grow them by bringing it all together and developing the supply chains for the things that they need to grow the hazelnuts, and also for processing and marketing afterwards. And so that's what our partners are doing. Next slide. So I show this slide not because I want you to know all these names, but because I want you to realize that we are standing on the shoulders of giants, that our work with hybrid hazelnuts is the product of the work of many, many other people who came before us. Many of you will be familiar with Badger Set, founded by Phil and Mary Rudder in about 1981. But they got their material from other breeders who got their material from other breeders, and so forth. Since Badger Set, other people have picked up Badger Set material and are working with it and moving it on, including UMHDI. So it's a long progression, many generations. What I want to say about Badger Set's breeding system is that they used a process called recurrent selection, which is basically identify the best, plant it out, repeat. And over generations, it's a system that works. The problem with it is that it's very, very slow. And peasant farmers going back thousands of years had time to make progress with that system. When now, because of the environmental crises that we are facing that Kurt has outlined, we don't feel like we have time for that anymore. And that's why UMHDI is enlisting modern genomic methods to make faster progress with the breeding. So I don't mean to disparage what Phil Rudder did at all. He made a huge contribution. No doubt the material that Badger Set sold was higher quality genetics than anything previous to that. But there's progress yet to be made. Next slide.
Got about 5 minutes, Lois.
I've done 5 minutes?
No, 5 to go.
I have 5 to go. Okay. All right. So the first thing that we're breeding for is Eastern filbert blight resistance, which is found in the Native American hazelnuts. It is not found in the European hazelnuts. And the original crosses were made in the 1910s by breeders who recognized the potential of crossing the Native Americans for the resistance and also for the regional climate adaptability with the European hazelnuts that had already been domesticated for larger nut size and better shelling characteristics. Badger Set material has a high level of resistance compared to the European material, but it is not completely resistant. And I won't even claim that UMHDI's material is completely resistant. So far, it seems to be, but diseases also evolve. And so we have to be on our toes with that. Next slide. So the Badger Set seedlings found in the landscape are seedlings. That means they're propagated from seeds, and they're open pollinated seedlings. A Badger Set might sell half-sib families, which means that they know what the mother plant is, but they could have been pollinated by anything. So what that means is that they've got the genetic diversity of a litter of feral cats. And some of the nuts might be excellent, and most of them would not. And many of them don't even bear nuts. So one of our growers found that they did a detailed survey of their farm and found that, I don't remember the exact statistics, but I think it was like 1 plant per row. And assuming the rows were 40 plants long, I know this farm, only 1 plant per row was worth harvesting at all. So it's really impossible to make a living with those kinds of yields and that kind of genetic diversity. The photo on the left shows 2 bushes that are half sibs growing right next to each other. One is mature, nuts dropping to the ground. The other one, the nuts are nowhere near mature. So you can't really mechanically harvest efficiently on that time. But the advantage is that there's a lot of ecological resilience, which our people really value ecological resilience. And it's actually also a plant breeder's dream. Next slide. So Badger Set sold seedlings to a lot of people. And when we started in 2007, each dot represents somebody we knew who had hazelnuts on their landscape. So we started by going around talking to these farmers and saying, hey, show us your best individual plants. These are just 2 of the people that we got plants from. Next slide. And what we did is we vegetatively propagated them through mound layering and brought them all together into common farms, replicated trials under uniform conditions. And the reason for doing that is because the best plants on any individual farm might be best just because they happen to grow on top of where a cow died and was buried. And, they had all the nutrients, the perfect microclimate. That might be why that plant is doing so well. It might not have anything to do with its genetics. So in order to parse through that, we needed to put them into trials that were uniform within the trial, but replicated. So we had 3 or more copies of each plant in the planting. And if we saw consistently the same one was doing well throughout the planting, even on the north side and the south side, then we knew it truly was a good plant. And it was an even better plant if it did well in St. Paul and also in Lamberton and also in Bayfield, Wisconsin. 3 very, very different kinds of climates and soils.
Sorry, Lois, I got to give you the 1 minute warning.
Okay. So anyway, next slide. These are some of the slides, some of the trials that we had. Next slide. And I can talk about this in more detail later. So next slide. Machine harvesting. This is a blueberry picker, which works. We've got a team working on even better stuff. Next slide. And these are 4 of the first 5 to come through our process. And next slide. But we are moving forward and continuing making crosses, bringing in genetics from other places, other breeding programs to get even better stuff. Next slide. And this is an example of some of the plantings with our 2nd generation material. Final slide. So we've made progress with the breeding, and we've also made progress with the agronomics, except what we found is that a lot of the agronomics are highly genetic, germplasm specific. And so we haven't been able to really hone in on that very well with our small scale university trials. And that's why we're now feeling like we need to go bigger, which is why we're enlisting people like Kurt to help us figure out some of these details on the larger system. Also because our university trials are too small to use that harvesting equipment. And finally, the industry infrastructure. We've got a processing facility. My colleague Jason Fischbach up in Bayfield, Wisconsin, has developed a wonderful processing line with a lot of help from growers. But they need more volume. They need more people to grow hazelnuts to make it worthwhile. And we need to have a processing line in Minnesota. So an American Hazelnut Company, which is a grower-owned hazelnut processing and marketing, basically a co-op. Officially, it's not a co-op, but they need more volume. So that's why we decided it was time to upscale with Go First Farm. And that's all.
Thanks, Lois. Thank you, Lois. I'm now going to briefly share how the University of Minnesota Forever Green, and specifically our commercialization team, kind of merged into this work. I should just mention, as Lois mentioned, there's many, many people advancing hazelnuts. We're just one of them, and we're fairly new to the game, at least for my team. And I'll just share a little bit about how we're involved in this Go First Farm strategy. Next slide. Just a quick reminder, Forever Green is a research and development platform housed at the University of Minnesota that's developing 15 new perennial and winter annual crops. If you go to the next slide. Our basic theory of change, you can just populate this whole slide, Andrew, is kind of this tripartite process of basically developing new crops, working through market uptake and grower uptake through commercialization, adoption, and scaling, and then creating a favorable social, policy, and cultural environment. This is a virtuous cycle we need to go through of improve the technology, get a market win, create a favorable social environment. Rinse, repeat. This is how new technology portfolios often move into the world. Next slide. Our team started in 2019. Next slide. It now looks like this. We're about a 5 FTE group that spans that whole portfolio. So we're kept very busy across perennials, winter annuals, and agroforestry. Next slide. Maybe some of you have heard of the parable of the blind people and the elephant. There are many aspects to commercializing new crops. These are some of those factors. We often focus on one, but it's a multifaceted challenge of developing new technologies, introducing them into the world, and changing systems. Next slide. There's a whole ton of research with like a lot of figures that look like this, lots of circles and arrows and dots, but our question is really, how do we do it in real time with real people? And so I've tried to communicate that a little more effectively in the following slide on the 4 main areas that we work, which is in strategy, capacity, resources, and policy and systems change. I've got examples for every single one of these pithy little comments under each category as examples of the many ways that we do that, but I'm going to not focus on those examples for now. Next slide. Okay, so we're gonna have a quick cameo by someone many of us know. If you press the little play button, there's about a 1-minute video that introduces the Go First Farm concept. Do we have audio on this or no? Can you turn your audio on, Andrew?
No. Help, how do I get the audio?
Kurt's running this.
Yeah. Any advice how I get the audio to share?
It should be on, but if it's not, you could play the video and I could introduce the concept. Yeah, so in this video, Jason Fischbach is describing the work that Lois largely ran through, and then talked about the next phase of this work, which is really to move the first gen selections out of UMHDI onto farm at early commercial scale. And so I should mention, Go First Farm, this is specifically for the UMHDI's first gen selections and material. Obviously, there's tons of people growing hazelnuts. The point is that this material coming out of this 15-year plus research and development program is now moving out on farm, and that's why Jason selected the Go First Farm language. And so Wisconsin, as of this video, had 3 of these first Go First Farms established. I think they're now on their 5th. And these are basically multi-purpose farms that will serve as an extension of the research and development program, farmer education and training, and also early commercial activity. Each one is projected to be about, between 5 to 15 acres in scale, with about an average of a 10-acre planting. And the collaboration with Kurt that we'll move into talking about further here is the first extension of this Go First Farm model into Minnesota, which is important because UMHDI is a multi-state collaboration. So you can go to the next slide. Jason says it better. Can you advance? Thanks. Okay, so something our commercialization team really focuses in, we've done this for Kernza, we've done this for our winter barley program, we've done this for a number of other new varieties we've developed of new crops. You need a strategy about how to put a new crop or new technology into the market. So specifically, you need a technology transfer, adoption, and diffusion strategy. And so like we've done for Kernza, the way we decided to structure this was we should go out to our partners and communicate effectively. We developed this Go First Farm recruitment brief. We distributed that to partners. We got interest from about 15 different parties. That brief, by the way, was, I believe, 4 pages long and tried to answer as many questions as possible about what it meant to be a Go First Farm partner. I think basically institutions have to communicate effectively in relationship with other people to accomplish their goals. It sounds simple, but it's surprisingly hard for institutions sometimes. We interviewed about 8 Go First Farm site partners or prospective partners, and we visited about 5 of those, and Kimber Contours was selected as our first Minnesota-based Go First Farm. And then for this first phase of establishment, we brought team planning support, controlled cross plants from the U of M greenhouse, going to this project, and about $30,000 in support for this first project to have a really, what we hope to be a successful Go First Farm base of operations in Minnesota. Next slide. I think I'm going to skip over. Oh yeah, go ahead. So then back to Andrew and Kurt to talk about our first phase of establishment. And gentlemen, we did get the note that we need to wrap this whole session at 10:15.
Yeah, thanks, Colin. We'll breeze through these and make sure we have enough time for questions. Okay, next slide. Yeah, so this is Kimber Contours. We can go to the next slide. I'm going to frame my discussion around this planting that we did this past fall around 3 concepts of collaboration, adaptability, and balance. So this is looking at the 5-acre site. This is the Kernza field facing south. Feel free to jump in at any time, Kurt.
Yeah, yeah,
Next.
sounds good.
Next slide.
I guess just the one thing you'll note is how the field rises going to the south, and was part of the erosion threat.
So with the help of Caleb Langworthy, again, great collaborator, we pulled the farm into Overyield agroforestry design software and designed the Hazelnut farm planting, which is the orange area you can see there that Kurt is highlighting. Next slide. And then we pulled that. Oh no, sorry. Before that, we planted about 1 acre or 250 pounds of low-mow fescue into the basically the outer rows, which is what we planted this fall. This is a friend of Kurt's using an overseeder. So we were able to leverage a lot of Kurt's friends in this project. Another importance of collaboration and relationships. We pulled the overyield design into Kurt's RTK navigation system in his tractor, and Colin and I followed along behind him to mark out where the holes were going to be dug. And one note on adaptability here. I initially bought 2 cans of the spray marking paint for this project, thinking that would be plenty. Kurt mentioned that maybe that might not be enough. So I showed up to this day of marking with 4 cans of paint. And at the end of the day, we had used 10 cans of paint. So always leave enough time to run to the hardware store. Next slide.
I'll just add one comment there. The reason we're marking that out is because these hazels are planted on contour, along with the Kimber Contours philosophy and management system.
Yes. So this is another one of Kurt's friends, a skid steer master, using a 36-inch auger bit that we had rented. So he's digging each of the holes. We dug about 500 holes for the plants. These are, again, along the 4 rows along the edges of the field. You can move to the next slide. It's a huge drill bit.
The one thing I'll say about that is we used a 36-inch bit, and going forward, I think we want to use either a 2 or a 2.5 foot bit. There were some issues with the hole being so large.
It was really big. We used that whole the bit to terminate the Kernza and also till the soil a little bit. But yes, it did potentially present extra weed pressures. Okay, so this is our Forever Green team manually preparing the holes for planting. Next slide. We got 2 tons of organic fertilizer from Sustain, a local supplier of high quality composted turkey litter. This is a wagon that we rented. So we looked into many fertilizer suppliers, but we wanted to keep the field organic. So we were trying to balance different needs and desires for this project. Next slide. And so these are the plants. So this is Lois demonstrating proper planting technique. And I think we ended up planting about 480 something plants. Correct me if I'm wrong, Lois. Next slide. We had to adjust our planting days a few times due to weather and the skid steer operator schedule. So we had to stay adaptable there as well. We acquired about 2,000 gallons of water from a local mill and elevator for the trees using a rented water trailer. Next slide. And we also bought 70 cubic yards of high quality wood chips for weed suppression. Next slide.
Just one thing I'll say about this is we just calculated the area of a circle times the number of circles times 6 inches deep to come up with the quantity of wood chips, and that came out to be pretty close. Andrew did a great job of finding some very nice wood chips to work with. I believe these are hardwood wood chips. They're not stringy, and hopefully they have no weed seed or weed trees in them. So just an important consideration.
I was promised that they wouldn't, but we'll find out, I guess. This is Kurt's family applying the last batch of wood chips to the plants.
And just I'll say this snowmobile trailer worked out great. It's at the right height and was very accessible from all sides. It's a 8 by 10 foot.
Yeah, so so that's what the trees look like now. Hopefully maybe a little bit bigger, but all in all, a really successful planting that like I said, came down to three things: collaboration, adaptability, and balance. In terms of collaboration, first off, partnering with Kurt was kind of a no-brainer. He's a long-time Forever Green grower. He's grown Kernza and a number of other Forever Green crops. He's super engaged. He's a very experienced grower. He cares deeply about the land, and he's going to care deeply about these plants. We have a high level of trust among the parties, and hopefully we can find future partners for these Go First farms with the same level of trust, or we can develop that level of trust to the same degree. In terms of adaptability, we laid out a pretty good plan. But as you all know, as growers specifically know, you get into the field and things look really different and you have to adjust. We got really lucky in terms of the weather. We had a few delays here and there and we had to adjust for partner schedules and that kind of thing. But Kurt and his family, Lois and her team, and the Forever Green team, we were all committed to making this work. And then balance. This is a really important first establishment in Minnesota, and we want to establish hubs of regional hazelnut research and commercialization. So this needs to be a successful model, but as a model, it also needs to be replicable, right? So there are many considerations that we have to balance, and the university has funding. Forever Green has some funding, but often we're choosing between ideal vendors or vendors that may not have existing relationships, and it's often difficult to establish new relationships or new suppliers with the university, and that can take many months. So we're constantly balancing these priorities and the needs of the project, the needs of the plants, lining up volunteer labor, lining up rental equipment, narrow planting time, soil conditions. So I think we threaded the needle pretty well here on this first planting, but we'll have to see how the next ones go. So we learned a ton, and hopefully we'll keep getting better at this.
I would like to interject a clarification about the plant material, is that we were planting the pollinator rows, which means we were planting seedlings from pots, and these were controlled cross seedlings. So in my presentation, I had 2 slides about controlled crosses. So the reason for these, we had 2 pollinator rows on one side of the contour and 2 pollinator rows on the other side of the contour. And we will fill in the middle with our clonal material later on. The reason for pollinator rows, there are 2 reasons for them. Yes, they're going to be very, very genetically diverse. But one of the reasons is that hazelnuts are self-incompatible. And so they need pollination from something that's different. And by having genetically diverse material, we are going to have enough pollen that we're confident that the clonal material will be pollinated. The other reason is because of ecological diversity, ecological resilience, plus these rows will be continued to be evaluated by the University of Minnesota as part of our breeding program.
I suggest there's a lot of great questions flying in the chat. If anyone wants to voice any overall comment or question, we could probably take a few and then we'll wrap in 5 minutes. Does anyone out there have a comment or question you want to voice?
Caleb, have you been...
Jono asks if there's any vole or rabbit protection on the trees.
No. What our strategy is to keep it open. And we do want to put some raptor roosts up. But we're not close to any woods. There are some trees, probably, I don't know, several hundred yards away, something like that, but it's kind of an agricultural field.
Another question is, were there concerns about nitrogen leaching from the wood chips?
No, they're on the surface.
You mean, I think the question's probably, is there concerns about nitrogen tie-up from the wood chips? And the answer is no, because the wood chips are on the surface and the tie-up occurs where at the interface between the wood chips and the soil. And there's minimal interface there.
Emily asks, when might anyone be able to start offering clonal plants for production scale plantings?
Aha.
Great question. Well, we don't have a great amount of time to go into it, but I will just mention that a segment we wanted to include was a little bit of a preview about how the UMHDI Go First Farm network plays into a commercial strategy of basically a commercial spin out of UMHDI that we hope will enable the broader industry in partnership with like a lot of people on this call. And so these first 5 cultivars being ready to move out into the world, we are in the process of building a 5-stacked enterprise spin out, one of which would be around plants. And those 5 stacked enterprises are plants, Go First Farm network, mechanical harvest, processing, and then markets and brand. And so the plants business, specifically right now, UMHDI is working with 4 nurseries on PMTA to experiment and increase the clonal plant material availability. And this plants business would effectively be in the business of prioritizing allocation of that material, also pooling orders to negotiate on behalf of growers with nurseries to get higher quality standards as well as more affordable prices. So long story short, we don't think that clonal material will be available for probably to the broad public out of UMHDI at least for several years. Because the prioritized deployment of this material is first to Go First Farms, then to organize grower groups. We hope to have some available in the next year or two, and then moving on to broader, public availability. So propagation has been the main bottleneck. I don't mean to speak for, I'm not the R&D person. I'm just kind of giving the synopsis of how plant availability also factors into the commercial strategy. As long as we just have, go ahead. And then I had one last comment before we close.
Yeah, I would just say, would this be accurate, Colin? If people, please contact UMHDI about plant materials so that we can, work together and keep people apprised of what's available.
Yes. Yeah. My last comment is that we are actively recruiting for other Minnesota Go First Farm partners, as is Wisconsin. So folks interested in Minnesota that would like to replicate this model and be, a long-term partner to Forever Green, UMHDI, and work with a network of peers can get in touch with me, can get in touch with Kurt, and we'd be glad to collaborate with you. And then, Kurt, I want to give you the last word to you on how you feel this is all going and where it's headed.
So what I'll say is, Andrew talked about being flexible and adaptable. I feel like our planting went very well. I refer to it as a no compromises implementation. Not to say there wasn't some scrambling in there and some good fortune from Mother Nature. We'd been in a 2-month drought, and then we got a couple inches of rain right before the planting. So that really made a lot of difference. But and then let's we need to build these scalable, replicable alternative systems that to address what's these existential threats that are in front of not just humans, but half of the species in the in creation. So
thanks, everyone.
All right. Thank you all for your time, and I'll see you in the next session.
Thanks, everyone.